A scientific-sounding rocket triggered a nuclear false alarm. Not a missile, not a warhead, a science experiment launched by researchers who just wanted to look at the northern lights. But that's not even the strangest part. Russian authorities were notified through diplomatic channels, but the warning didn't reach the operators who needed it. The launch had been announced in advance, filed through the proper diplomatic channels. Someone, somewhere, had the paperwork. And yet, on the morning of January 25, 1995, the Russian military watched a single rocket rise off the coast of Norway and couldn't agree on what it was. The next 10 minutes would be one of the most dangerous 10 minutes of the post-Cold War era. Most people, when they think about nuclear close calls, picture the Cuban Missile Crisis. 13 days of televised tension, world leaders staring each other down, history happening in slow motion. But one of the lesser-known close calls involving nuclear command systems happened so quietly that most of the world didn't hear about it for months. No cameras, no press conferences. Just a briefcase, an aging radar system, and a rocket carrying scientific instruments climbing into the Arctic sky. Here's what makes it impossible to understand. At first glance, the Cold War was over. The Soviet Union had dissolved more than 3 years earlier. Russia and the United States were, by any formal definition, no longer enemies. And yet, the machinery of mutual annihilation was still running, still watching, still calculating, still primed to fire within minutes of a signal that looked wrong enough. That machinery almost fired. To understand how, you have to understand what Russia was looking at that morning. Not just the radar return. The whole picture. The geography, the doctrine, the decade of paranoia baked into every protocol, every tripwire, every automated assumption about what a rising object off the Norwegian coast could possibly mean. Because the answer the radar gave was not weather rocket. The answer was submarine-launched ballistic missile, possibly nuclear. Trajectory consistent with a decapitation strike. And in 1995, that answer, even a wrong one, triggered a rare high-level escalation. Start with the geography, because geography is where this whole story lives. Norway occupies a particular piece of the planet that the Soviet military had spent 40 years treating as one of the most sensitive corridors on Earth. Its northern coastline bends around the top of Scandinavia and points directly toward the Kola Peninsula, the stretch of Russian Arctic that housed and still houses a massive concentration of nuclear submarines and their land-based support infrastructure. Why did that geography matter so much to the people watching the radar? The Norwegian Sea, the BRANT XII, the waters between them. This was the operational theater, where Soviet ballistic missile submarines ran their patrols during the Cold War, staying beneath the surface, waiting for orders that everyone hoped would never come. From that same geography, American submarines could approach close enough to launch missiles that would reach Russian territory within minutes. That proximity was intentional. It was a deterrent. It was also a permanent source of existential anxiety for the people whose job it was to watch for exactly that. So when Russian early warning radar detected a rocket rising from somewhere near the Norwegian island of Andøya on the morning of January 25th, the system didn't process it as an anomaly. It processed it as a possibility. A threat envelope that matched what a Trident II submarine-launched ballistic missile would look like in its early ascent phase. Now, what is the Black BRANT XIII? It's a Canadian-built sounding rocket. Sounding, as in measuring. Taking samples. Reaching into the upper atmosphere and returning data. It's not a weapons platform. It never has been. On that particular morning, it was carrying scientific instruments designed to study how solar wind interacts with the Earth's magnetic field near the poles. the phenomenon that produces the aurora borealis. The research team included Norwegian and American scientists. The rocket was launched from the Andøya rocket range, which is a facility that had been conducting exactly this kind of scientific launch for decades. There was nothing covert about it. There was nothing unusual about it. Except for one thing. The black BRANT XII at launch looks almost nothing like a weapon. But in the first minutes of its trajectory, as it accelerates upward and its radar return takes shape, particularly from certain angles and certain distances, it can produce a signature that overlaps uncomfortably with a specific type of threat. A Trident submarine-launched missile, in its boost phase, follows a steep initial ascent. So does a sounding rocket. The radar cross-section varies by model and altitude. The velocity curves aren't identical, but they're close enough to pass through the first layer of automated filtering without being dismissed. What happened next is where the story splits into two parallel tracks that are each, on their own, completely logical and together nearly catastrophic. Track 1. The rocket. The black BRANT XII was launched early that morning. The research team had chosen the date and time to capture a specific atmospheric condition. The launch was nominal. The rocket performed exactly as designed. It climbed. It arced. It released its scientific payload at altitude, and then it began to descend. The entire flight would last about 24 minutes. Track 2. Russia's early warning system. Russia's early warning system, which included the OKO satellites, processed data from a network of large phased array radar stations across Russia's northern and western frontiers. A continuous watch, an automated threat detection architecture, a pipeline of signals that fed into a room full of analysts whose job was to separate noise from signal. On the morning of January 25th, Russia's early warning system received a radar return that matched the profile of a submarine-launched ballistic missile. The duty officer on watch accounts differ on exactly who was present and what decisions were made at what level. Had a problem. He had a contact. The contact behaved like a threat. The early warning protocols that governed his response required escalation if the contact crossed certain thresholds within a certain time window. It crossed them. The notification went up the chain. This is the part that almost no one who lived through the Cold War and survived it unscathed had ever expected to see happen in 1995. It turns out the structure that had kept the peace for 4 decades was still treating the world as if the Cold War had never ended. Here's what Russian Nuclear Command Authority looked like in that moment. The nuclear briefcase, called the Chejet, named after a mountain in the Caucasus, was not a single object. It was a system. 3 briefcases, to be precise, one held by the president, one by the defense minister, one by the chief of the general staff. The briefcases contained secure communication equipment that, in coordination, gave the holder the ability to authorize a nuclear launch. On the morning of January 25, 1995, the Chejet held by Russian President Boris Yeltsin was activated. Not theoretically, not in a drill, actually activated. In what is widely described as a first in public reporting, Yeltsin was alerted and the Chejet system was brought into use. Yeltsin was briefed. The military chain of command was in communication. The contact was still being tracked. The question being asked in real time was, is this a weapon? And if so, where is it going? The trajectory is what saved everything. This is the moment where the geometry of the situation, the specific arc of a BRANT XII versus the specific arc of a Trident II became the entire ballgame. A Trident II fired from a submarine in the Norwegian Sea aimed at Moscow or at the command infrastructure on the Kola Peninsula, would follow a particular parabolic path. It would reach a certain altitude. It would begin to curve in a certain direction at a certain point in its flight. The black BRANT XIV did not do that. As the rocket climbed past its initial ascent and began to follow its designed trajectory, the trajectory of a scientific instrument going up, sampling, and coming back down, the radar picture changed. The contact didn't arc toward Russian territory. It didn't follow the expected path of a weapon seeking a target. It continued upward, and then, critically, it went somewhere a missile wouldn't go. The Russian military had, depending on which account you read, about 8 to 10 minutes from initial detection to the point where the contact would have to be a missile or wouldn't be. The window was tight. It was tighter than most people understood at the time. The protocols that governed launch authority for a retaliatory strike assumed a response window measured in minutes, not hours, because a submarine-launched missile fired at close range doesn't give you hours. Within that window, the trajectory resolved. The contact was not heading toward Russia. The Chejet was deactivated. The alert stood down, and 24 minutes after it left the ground, the black BRANT XX completed its flight, and the scientific team at Andoya began recovering their data. The world didn't know. This is the detail that tends to land differently depending on how you come to it. The incident was not immediately announced. It was not broadcast. There was no emergency statement from the Kremlin, no joint press release, no diplomatic communique explaining what had almost happened. It wasn't widely publicized in real time. Fuller accounts emerged later, through the kinds of channels that defense and arms control communities use to share information that governments haven't formally released. By the time a coherent account of the morning reached the general public, the news cycle had moved on, and most people filed it somewhere between close call and don't think about it too hard. But here's the question that the incident leaves permanently open. What was the failure? Because there was a failure. Something went wrong. Not the rocket. The rocket did exactly what it was supposed to do. Not the radar. The radar detected a real object and processed a return that was, within its technical parameters, ambiguous. Not the analysts who escalated according to protocol when protocol said to escalate. The failure was the warning. Norway had told Russia. So what exactly broke down between the notification and the watch floor? This is the part of the story that makes the whole thing not just dangerous, but structurally embarrassing for every institution involved. The Norwegian government, following the procedures that existed for exactly this purpose, had notified Russian authorities in advance of the launch. The notification had gone through the right channels. It had been received. It existed in the system. It just hadn't made it to the operators watching the screens. Somewhere in the bureaucratic distance between the diplomatic notification and the operational watch floor, the warning stopped traveling. It sat in an inbox, or a database, or a folder, somewhere that was technically received, but functionally invisible to the people who needed to know. The duty officers watching the radar that morning had no record of a scheduled Norwegian rocket launch. Nothing in their briefing materials flagged it. When the contact appeared, they had no context that would have let them say, "Wait, we knew about this." That gap between the warning that was sent and the warning that arrived is the mechanism of the near miss. So why does a gap like that exist? The answer involves several things happening simultaneously, none of which individually would have caused the problem, but all of which together created it. First, The Soviet early warning system was designed and built during a period when the information flowing through diplomatic channels was treated, almost by definition, as suspect. Soviet protocols for what got communicated to operational watch floors were not built around the assumption of good faith scientific notifications from NATO neighbors. They were built around the assumption that anything coming over the wire from the West was either propaganda, misdirection, or irrelevant. The channels that carried scientific launch notifications and the channels that fed operational intelligence into early warning stations were not well connected. They weren't supposed to be. Second, by 1995, those systems hadn't been rebuilt. The Soviet Union had dissolved. Russia had inherited the infrastructure, but the logic baked into the infrastructure, the logic of permanent adversarial watchfulness, of treating every radar contact as a potential first strike until it demonstrably wasn't, that logic didn't dissolve with the Union. It continued operating. Third, the early 1990s were a period of enormous institutional stress for the Russian military. Budgets had collapsed. Equipment was aging. Personnel were underpaid and in some cases unpaid. The human layer of the early warning network, the analysts, the duty officers, the people who should theoretically have caught a misfiled notification and flagged it before it became a crisis, was operating under conditions that made that kind of careful cross-referencing much harder than it had been a decade earlier. None of these facts are an excuse, but they are the explanation. The system that nearly launched a nuclear response to a scientific-sounding rocket was not a conspiracy, not a rogue actor, not a failure of individual judgment. It was a legacy, a massive, aging, institutional legacy that had been optimized for a world that no longer existed, running on the same logic in a world that had changed around it. Put yourself in the room. Not the research facility at Andoya. The other room. It's early morning. You are a duty officer at an early warning station. You have been watching screens for hours. The watch rotation is long, the equipment is old, and the institutional memory of the last 4 decades has told every person who has ever sat in that chair, that the threat you're watching for is real, that it is possible, and that the window in which you have to act is shorter than most people's morning commute. A contact appears. It looks like a submarine-launched ballistic missile. Your protocols are clear. Your job is to escalate. So you escalate. What you do not know, what you cannot know, because the information never reached you, is that the contact is a Norwegian weather rocket whose launch was filed with Russian authorities more than 3 weeks ago. What you do not know is that the researchers who launched it are, at this exact moment, checking their instrumentation and hoping the upper atmosphere cooperates with their measurements. You know what your radar tells you. You know what your protocols require. You know what the stakes are if you don't act, and you're wrong. You escalate. The logic is unassailable, which is exactly what makes it terrifying. Now, consider Yeltsin. By January 1995, Boris Yeltsin was not a man in an uncomplicated position. He was governing a country in economic freefall. He was fighting a war in Chechnya that had begun just weeks earlier and was already going badly. His approval ratings were very low. The relationship between Russia and the West was complicated in ways that neither side had fully worked out. Formally friendly, substantively tense, full of unresolved questions about NATO expansion, about Russian sovereignty, about what the post-Cold War order was actually supposed to look like. And now, on a Wednesday morning in January, someone was telling him that a missile might be in the air. What we know about his response is limited. Russian officials who were present or briefed on the incident have confirmed the broad strokes. The Chege was activated. The military chain of command was in communication. A decision window opened and then closed when the trajectory resolved. What Yeltsin was thinking, what he said, what he considered, that's harder to establish. What we can say is that he waited. In the most critical sense, he did not authorize a launch. In the time available, the minutes between activation and resolution, the contact was tracked, the trajectory was analyzed, and the conclusion was reached that this was not a weapon. The protocol, this time, worked as it was supposed to work at the final stage. The decision that was never quite made was not made. But the fact that it was close enough to require a decision, that a sounding rocket launched by scientists studying the aurora borealis produced conditions under which the Russian president was sitting in front of an active nuclear command system with a live alert on the table, that is the part that doesn't resolve neatly. That part just sits there. There's a particular quality to the close calls that don't quite happen. The Cuban Missile Crisis ended with negotiation. The crises and accidents of the 1980s, Able Archer 83, the false alarm of September 1983 when the Soviet early warning satellite misread sunlight reflected off clouds as incoming missiles. Those ended with individual officers making judgment calls that held. The 1995 incident ended with geometry, with the specific arc of a rocket that didn't go where a weapon would go. Which means the margin combined two things: a trajectory that resolved the ambiguity, and the decision to wait long enough for it to do so. The rocket's path was always going to clarify itself, but only if the window was long enough, and only if no one acted before the trajectory finished resolving. This is the structure of the near miss that doesn't get talked about enough. The early warning system that detected the black BRANT XII was doing its job. The analysts who escalated were doing their jobs. The protocols that activated the Chejet were functioning correctly within their own logic. Every gear in the machine turned exactly as designed. The near miss happened inside the margins of a system that was working correctly, which means the near miss wasn't a malfunction. It was a design. The arms control community spent years after the incident examining what it revealed about the state of post-Cold War nuclear infrastructure. The conclusions were uncomfortable. The assumption that the end of the Cold War had meaningfully reduced nuclear risk turned out to be more complicated than it first appeared. The weapons still existed. The delivery systems still existed. The command and control infrastructure still existed. The operational protocols, the tripwires, the escalation chains, the launch windows still existed. What had changed was the political relationship between the countries. What had not changed, or had changed much more slowly, was the machinery that had been built to manage the conflict that relationship had defined. In the United States, this incident fed into ongoing debates about what was called de-alerting, the idea that nuclear forces should be moved off of their high alert posture, where they could be launched within minutes, to a lower alert status that built in more decision time. The logic was simple. If the launch window is 15 minutes and the decision window inside that is less than 10, then the structure of the system itself is what creates the pressure to act before you fully understood what you're acting on. Increase the decision time, and you reduce the probability that an ambiguous contact becomes a catastrophic choice. The debate went on for years. It continues in various forms today. What the 1995 incident demonstrated, concretely and undeniably, was that the ambiguity was real. Not theoretical, not a scenario in a think tank paper. Real. A real rocket. A real alert. A real president with a real briefcase. The ambiguity that the system was designed to resolve, weapon or not, launch or not, could be produced by a sounding rocket carrying scientific instruments into the upper atmosphere. If the geometry had been slightly different, if the black BRANT XII had followed a trajectory that looked just a few more degrees like a trident, there would have been no resolving ambiguity. There would have been a window in which the data looked like a threat right up until the moment of impact. What happens in that window is what the entire architecture of deterrence was built to answer. And in 1995, the architecture of deterrence turned out to depend on a rocket not going in the wrong direction. There's a reason this incident produced policy discussions rather than policy changes. Part of it is visibility. The Cuban Missile Crisis was public while it was happening. The fear was shared. The resolution was witnessed. When it ended, the world felt the weight of what had almost occurred, and that weight generated political will. The hotline between Moscow and Washington, the partial test ban treaty, the beginning of the arms control framework that would define the next 20 years. The 1995 incident was not public while it was happening. The weight of it arrived, if it arrived at all, as a press report months later, in a world still trying to process the collapse of the Soviet Union and the wars it had produced. The fear was not shared. It was reported. And reported fear, it turns out, generates less political will than experienced fear. The other part is institutional inertia. The early warning systems, the high alert postures, the launch on warning doctrines, these are not just technical configurations. They are the crystallized output of decades of strategic thinking, billions of dollars of investment, and entire institutional cultures built around specific threat models. Changing them requires not just a decision, but a reorganization of the logic that produced them. That kind of reorganization is hard even when everyone agrees it's necessary. When there's disagreement about whether the Cold War paradigm is really over, whether the threat has actually changed, whether reducing alert levels creates vulnerability rather than safety, it becomes nearly impossible. So the machinery remained. The procedures that failed to carry a Norwegian notification to a Russian watch floor were examined and updated. New protocols were developed. Hotlines were discussed and some were established. The relationship between Russian and American early warning systems became a subject of sustained diplomatic engagement, but the rockets stayed ready. There's a version of this story where the focus lands on the human element, on the individual decisions or non-decisions that kept the morning of January 25th from becoming something else, on Yeltsin, who waited, on whoever reviewed the trajectory data and said, "This isn't going where a weapon would go," on the researchers at Andoya who launched a rocket and went home without knowing that their instruments had briefly been mistaken for the opening move of a nuclear war. That version of the story is true, but it may be the less important version, because the human element, the people who waited, who looked again, who caught the trajectory before the window closed, is not a design feature. It's a residual. It's what happens when the designed response hasn't yet triggered, and the humans inside the system use the margin that remains. In 1995, the margin was 10 minutes, maybe less. In a different geometry, with a different trajectory, the margin would have been smaller. In a different political moment, a moment with higher tension, more recent provocation, less institutional caution, the margin might have been used differently. What the incident reveals, when you follow the thread far enough, is that the safety of the world on that particular morning rested less on the decisions of the people involved, and more on the flight path of a rocket that no one in the Russian military command had known to expect. That's a narrow margin. That's a very narrow margin. Here's the part that tends not to make it into the standard telling. After the alert stood down, after the Chejet was closed, after the military chain went back to normal watch, off day A, R, The contact resolved into a descending scientific instrument that was not a threat. The incident was documented. The failure in the notification chain was identified. The gap between the diplomatic warning and the operational briefing was closed, at least on paper. But the conditions that produced the gap didn't disappear. A bureaucratic communication failure is one kind of problem. You find where the notifications stop traveling, and you fix the handoff. You add a verification step. You make someone responsible for ensuring that scheduled foreign launches appear in the morning briefing of the relevant watch floors. That's solvable. Protocols were reviewed and revised, at least on paper. The harder problem is what lives underneath the communication failure. The assumptions baked into the system. The operational logic that says, when you see something that looks like this, you have minutes to decide, and the default in those minutes is escalation, not patience. The launch-on warning posture that compresses the decision window to the point where a bureaucratic gap in the notification chain becomes existential rather than administrative. Fixing the notification chain doesn't change the decision window. Fixing the notification chain doesn't change what happens the next time an ambiguous contact appears and there's no notification to check. The arms control debates that followed the 1995 incident are worth dwelling on for a moment because they illuminate something about how institutions respond to near misses that almost weren't witnessed. The core argument for maintaining high alert postures runs like this. The deterrent value of nuclear weapons depends on credibility. If your adversary believes that you can respond quickly and with overwhelming force, they are deterred from striking first. If you move your forces off alert, if you introduce delays, stand-down periods, demating of warheads from delivery systems, you reduce the perceived credibility of your response, and in doing so, you potentially reduce the deterrent effect that has, arguably, kept the peace between nuclear-armed states for decades. This is a serious argument. It is taken seriously by serious people. The counterargument runs like this. The system that produces this credibility is also the system that makes a scientific-sounding rocket into a potential trigger for nuclear war. The speed that makes the deterrent credible is the same speed that compresses the decision window past the point where human judgment can reliably function. You cannot have a system that is fast enough to be credible and also slow enough to never produce a catastrophic false alarm. At some level of tension, at some degree of technical or bureaucratic failure, the speed kills. Between these two arguments, in 1995 and for years afterward, the world made its choice mostly by not making a choice, by maintaining the postures that existed while discussing, in various forums, whether they should change. The rockets stayed ready. Let's go back to the beginning, because the beginning is where the strangeness lives. A scientific-sounding rocket triggered a nuclear false alarm. That sentence sounds like an exaggeration. It isn't. The correct version of the sentence might be more careful. A scientific-sounding rocket placed the Russian president in front of an active nuclear command system, with a live alert running and a decision window open in what is widely described as a first in public reporting. Whether that constitutes almost ending the world depends on what you think would have happened next. The people who study this incident tend to be careful about that question. They point out that the decision window closed without a launch. They point out that the trajectory resolved. They point out that the system, in the end, produced the right answer. But they also tend to point out something else. The night before the launch, the researchers at Andoya had no idea they would spend the next morning being mistaken for the opening shot of a nuclear war. They were scientists. They were studying the Aurora. The rocket they were launching had been launched, in various versions, hundreds of times before. It was routine. Routine is the word that keeps appearing when people who study near misses analyze how they happen. Not because routine produces carelessness, though it sometimes does, but because routine is the state in which the unexpected arrives. The Cuban Missile Crisis was not routine. Able Archer 83 was an exercise that some feared could be misread. The 1995 incident was, for everyone involved except the Russian early warning system, completely ordinary. The rocket went up. The radar saw it. The logic of the system did what the logic of the system was built to do. The only thing that made it ordinary, in the end, was the trajectory. What does it mean to live in a world where that margin is real? Not hypothetical, not abstract. Real, as in documented, confirmed, reconstructible from accounts that have been collected and analyzed and published. Real as in, on January 25, 1995, a black BRANT XII sounding rocket carrying atmospheric science instruments lifted off from a Norwegian island, and the Russian military watched it on radar and prepared to brief the president of Russia on a possible nuclear attack, and the decision system that could have authorized a launch in response was activated in what remains the only publicly documented instance of its kind. Real as in, the margin between that morning and something else was a flight path. The argument for thinking carefully about this, for not filing it under close call, resolved, never mind, is straightforward. The conditions that produced the 1995 incident were not unique to 1995. They were structural. They were the product of systems, doctrines, institutional arrangements, and communication gaps that existed before 1995 and, in various forms, continued afterward. The question is not, could this happen again? The question is, what would have to be different for it not to? And the answer to that question requires looking at what, specifically, almost made it happen in the first place. A high-alert posture that compressed the decision window to minutes. A notification system that failed to route a warning to the people who needed it. An early warning system interpreting an ambiguous radar return inside a protocol that treated ambiguity as threat. A political and institutional moment that had changed the relationship between the countries without changing the machinery built to manage their conflict. Fix those things. Really fix them. And the geometry of the rocket stops mattering. The ambiguous contact gets cross-referenced against a known launch schedule and resolves before it reaches the command level. The decision window is long enough that a flight path has time to demonstrate itself before anyone opens a briefcase. That's the version where it doesn't happen at all. The researchers at Andoya got their data. The solar wind measurements came back clean. The instruments had performed well. The aurora was doing what it was supposed to do, and the scientific picture that came back from the upper atmosphere was exactly what the team had hoped for. They published their results. Somewhere in Moscow, in a building that was not a research facility, the alert had stood down, and the cheja had been closed, and the watch had returned to its normal rhythms. The morning of January 25th became the afternoon, and then the evening, and then the day was over. The world that woke up the next morning was the same world that had gone to sleep the night before. Nobody who hadn't been in the specific rooms where it happened knew that anything had occurred. That's the thing about margins. They're only visible after you cross them, or after you almost do. The morning of January 25, 1995, produced a margin that held, a trajectory that resolved, a briefcase that was opened and closed without being used. The research team went back to work. The early warning analysts finished their shifts. Yeltsin went on to the rest of his day. And the rockets stayed ready. Go back to the first sentence. A scientific-sounding rocket triggered a nuclear false alarm. Here's what that sentence actually contains. The word almost is doing a lot of work. It's carrying the weight of a specific geometry, a specific decision window, a specific failure in a bureaucratic chain, and a specific set of institutional assumptions that survived the end of the Cold War intact enough to produce that morning. The almost exists because of all of those things together. Remove any one of them, and it's not an almost, it's a notification that gets filed and forgotten, a radar contact that gets cross-referenced against a known launch, and dismissed, a duty officer who checks his briefing materials and says, "Right, Norway told us about this." But they were all present simultaneously on the same morning. That's the architecture of the near miss. Not a single catastrophic failure. A constellation of ordinary ones. A filing gap, a radar signature, a protocol, a posture, each one unremarkable in isolation, each one essential to the whole. Which means the lesson that the incident offers is not that the system failed. The system, in most of its components, worked exactly as designed. The lesson is that a system working exactly as designed can still produce an outcome that nobody designed. And the outcome it almost produced, on a Wednesday morning in January, a few years after the Cold War ended, while a group of scientists studied the Northern Lights, was the one that every institution, every treaty, every deterrence doctrine, every diplomatic formula had spent half a century trying to prevent. The rocket came down. The briefcase was closed. The world continued. But the margin, the specific, geometric, bureaucratic, institutional margin that kept that morning from being something else, that margin was real. It was narrow, and the conditions that created it did not disappear when the alert stood down. They're still there. The rockets are still ready.